Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, today we will discuss one more numerical, number 7 on refraction of light using prism formula, refractive index and Snell's law. So let us solve the question number 7. Students, let's start the question number 7. The question says, there is a right angle prism through which 3 colors are sent, and we'll see out of these 3 how many are undergoing TIR, total internal reflections. So we have got blue, green and red. Three different colors are sent through this right angle prism. This angle is 90. This is given as 45 degree. This is also given as 45 degree. So all these rays will strike this surface, and if the angle of incidence is greater than critical angle, then only it will undergo total internal reflection, otherwise not. So how to find the critical angle for this condition? So let us find all the rays will strike definitely at an angle of 45 degree, because this is normal and this is 45, this is 90, because this is also a right angle prism. This is 90, this is 45, this has to be 45, so this angle is 45. This ray also will strike at an angle of 45. This ray also will strike at an angle of 45. So all these colors will strike at an angle of 45 degree. If the angle of incidence is greater than critical angle, then only it will undergo total internal reflection. Okay, so we'll see if total internal reflections is taking place for all these 3 rays, or 1 out of the 3, or 2 out of the 3, or all of them are undergoing TIR. So to find that, we have to find the refractive index responsible for critical angle. So here we know that one by sine C, or sine C is 1 upon mu. Here, if I consider 45 degree as the critical angle, this 45, then corresponding to this C as 45 degree, what refractive index we are having? So from here I write 1 upon sine 45, which is equal to root of 2. So mu comes out to be root of 2, that is 1.41. That means this is the critical, this at this refractive index, if this material has this refractive index 1.41, this material has refractive index 1.41, it will have critical angle of 45 degree. So I consider that this prism has refractive index 1.41. Now any ray which strikes at 45 degree, those who are having this value, all exactly this value, it will move along the surface, it will suffer critical angle. That means it will move along the surface. Any refractive index greater than this will always undergo total internal reflection. So therefore you can see the value of red, blue and green in the questions given are, I'll write the data for you. Blue, the refractive index given as 1.47. For green it is given as 1.44. For red it is given as 1.39. So these are the data given in the questions. So if refractive index is 1.41, then the ray for those light, the refractive index is this, and you can see from the data no one is having exactly 1.41, so no ray will move along the surface. If anyone is having this value, then that ray will move along the surface. If the ray, this value is greater than this value, if mu, these are the mu values, if mu is greater than this value, they will come out, they will undergo reflections, total internal reflections. So out of these, the ray which undergo total internal reflections are green is greater than this, is 1.44 is greater than 1.41, so the green light will undergo total internal reflection. The blue light is having 1.47, it will also undergo total internal reflections, because we know that greater the value of mu, smaller is the angle of refraction, angle, critical angle for that, so that will undergo therefore total internal reflections. The red one is having this mu which is less than this, so it will not undergo total internal reflections, so the red light traveling all the way to this surface will come out. The red will come out and other two rays will undergo total internal reflections. So in this process we separate the red from the rest of the two colors. So since mu for red is less than 1.41, it will not undergo TIR, so it comes out of the prism. From blue and green. Okay, thank you.